We shall try 9.3 now. We'll continue from the same chapter, that is chapter 9, circle, class 10, the theorem 9.3. After finishing your 9.1 and 9.2, where we did in the first class 9.1, and after that 9.2, in today itself I released the video that had 3 different cases. I'll not revise that. Kindly go to the video again and just reread it. And now the third one, 9.3, it is like this. It's a simple theorem. Circle, chapter is 9, for class 10. Okay, you have page number, we are at page number 193. This is page 193 of your textbook, MBAC textbook, page number 193. Okay, here it's a simple theorem. I think in class 9 also somewhere you must have come across this. It is like this. Theorem 9.3. How to write? First you will write it, the things that I'm writing it here, and sometimes I'll do some rough work also that you need not write it. Of course, after some time I'll tell you what to write and what not. The angle in a semicircle is a right angle. RIGHT, right angle. So this is very simple compared to 9.2. Only one case will be discussed here, and it is like this. What is the meaning of this theorem? The meaning is that suppose you have a circle and we need semicircle. Semicircle means from the center it passes like this. Suppose this is the center O, maybe this is, you call it AB, the diameter. This is called semicircle, this is called the other semicircle. In a circle you can have 2 semicircles because half of the one circle is semicircle. Now the angle in a semicircle is a right angle. What is that angle? This is the angle. Okay, you can make another angle also. If you want, you can make like this also. Join the 2 lines. APB is an angle, the one we are talking about here. AQB is also an angle. Okay, you can write many other angles also like this. PQ, suppose this is R. ARB, this is also an angle in the semicircle. But there is one thing common in all these angles, wherever you draw the point, either it be here, 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 anywhere, even this side also, you will find it one interesting thing that all these angles are 90 degree, right angle. Okay, that we have to prove. After that, whenever you blindly you draw one circle and you know this is the diameter, and if it is like this, that means you can know this is the 90 degree. Okay, so in order to use it in future, we will prove it for once now. Okay, that is the theorem. Every time the theorem says that, you have to prove the rule, and after that you are going to use it. And it is not that difficult. It looks difficult only because there are a lot of talk there given to prove this, that, but the thing is very simple. Now in mathematical language, what we do, we write first the given. There is a circle. Of course there has to be a circle in order to have a semicircle. Circle with center O, center O, AB is the diameter. Suppose this is the diameter in the circle, and angle ACB is the angle in the semicircle. Angle in the semicircle. Okay. Now what is the next thing? The theorem, what it says? Prove it. It is a right triangle, right angle. So what that I'll do here is to prove. First we need to visualize what we are writing. Diagram. Center. The center AB is the diameter. AB is the diameter. To that, ACB is the angle that we are talking about. Make it anywhere. You can make it here. Join it here. You practice more and more so that your free hand also should go somewhat straight. Okay, so that you can not waste too much time drawing with a scale. So this angle is 90 degrees. This we have to prove. Okay. The known things are that it is a circle. Known things is that it is a diameter. But unknown thing is that ACB has to be 90 degrees. So that we are going to prove it here. What we will write it here? Angle ACB equal to 90 degree. Okay. Now we start with the proof of this. What we do it here? We will refer the theorem number 9.2. Remember in 9.2 something like this happened in the case 2. In the case 2 what happened? If suppose this is the arc, if you have understood 9.2 very well, you will easily understand this. If this is the arc, then the angle made by the arc at the center has to be double the angle made on the remaining part of the circle. Arc, this is that. So this is that angle and this is that angle. So that exactly we will refer it and we will write it there. Okay. As the angle, this is what we are writing is the theorem number 9.2. As the angle subtended by an arc, here the arc is AB, okay, this side, this arc, by an arc at the center, this arc at the center is double the angle, double of the angle. Which angle I am talking about now? This angle. Double the angle subtended by it at any point, anywhere here, anywhere point from A to B, anywhere point on the remaining. You know the meaning of remaining here? On the remaining. Now this is already the arc, so remaining part is this one. Okay, remaining part is this one. So where I chose? Here. The remaining part of the circle. This is a known fact. 9.2 is already proved. Remember 9.2 already proved. So that means 9.2 results are usable. What it says, this angle has to be double of this. So what I write, what I know from here is that I will know angle AOB, this angle, this is the center O, AOB, this angle must be equal to double of ACB. Angle ACB. This angle has to be double of that. Why? This is the reason. Because 9.2 says that whenever this happens, the other side of the angle will be half of it or double of the half other one. So this is 9.2. So 9.2 enables me to find out 9.3. So one more thing interesting is that AB is a straight line. You can see a diameter. Diameter is always a straight line. So what does that mean? That means that AOB is a 90 degree, 180 degree. This also implies and what I am writing is left side on the right side on the left, nothing special. So 2 I am going to send it here, 1/2 of angle AOC. This is half of that. I send it here, it will go in the denominator. Okay, about to finish now. Now what you will find is that since, as we know, AOC is a straight line, so angle AOC is 180 degree. You go and see your protector, you will see the straight line is 180 degree, isn't it? So this is what AOC is, what angle? No bending, that means 180 degree. So if it is like this, what does that mean? Here I can put 180 degree. Hence, angle ACB, I'm picking up here, ACB will be equal to half into, in the place of AOC I'm going to write 180 degree. When I cancel them, what I'm going to get it? If I cancel them, I'm going to get angle ACB equal to 90 degree. This is what I want to prove. Now, even if I change the point AC somewhere here, there, same result will follow and you will get the answer same 90. This is what I wanted to prove. Angle ACB is 90 degree. So very easy. 9.2 if you know, that means automatically you are knowing what is 9.3 also. Okay. Thank you. We'll do some other things also after a short break. Thank you.